Welcome back. We're going to go through two sections today. I'm pretty sure the first section is something we don't have to work on. It's something that's valuable to note, and probably something that you've seen enough times that it's kind of in your head, although you won't necessarily have thought about all the different possibilities. So it's section 4.3 in the text, called equivalent trig ratios. And if we just kind of look at our basic 30, 60, 90 triangle, the one that we started with way back in grade 10 at some point, you would have looked at those specific angles. And you probably would have seen that sine of 60 is equal to cos of 30, and vice versa. Sine of 45, if you ever sort of paid attention to it, is the same as cos of 45, but that doesn't really necessarily mean too much to you until you start to look at kind of the patterning that works. Turns out that sine of 80 is equal to cos of 10, sine of 90 is equal to cos of 0, and so on. So if we're looking at this in terms of radians specifically, since we're working in radians, I just kind of listed off the basics here for sine, cos, tan, and then I've got the reciprocal ratios down below. In green, you see all the ratios dealing with the pi over 3. In blue, all the ratios dealing with pi over 6. And what we end up recognizing, or starting to recognize, is again, those patterns that are there, not just for sine and cos. And here's my sine of pi over 3. Here's my cos of pi over 6. Here's my cos of pi over 3. Here's my sine of pi over 6, and so on. But there are other angles, there are other similar patterns that develop. And just sort of quickly here, just noticing off the top, sine of an angle will be equal to cos of 90 minus that angle, or pi over 2 minus that angle. Cos of the angle will be equal to sine. And then if you start looking at the others, we've got, let's see, tan right here of pi over 3 is root 3. We have a root 3 over here at cotan of pi over 6. We have a secant here of pi over 3 equal to 2, and a cosecant here as well. And there's a whole bunch of other sort of combinations there that exist. So section 4.3 just kind of has you playing with those and solving questions where instead of using tan of a given angle, I can substitute in cotan and so on. Again, I don't know that it's all that necessary for us to go through them, but they list off all of these as possibilities. Now, you're not going to ever memorize these, but you might recognize that there's a whole lot of repeat in there. Same sort of thing as with the, when I look at sine being equal to cos of pi over 2 minus x. So we could sort of look at it in terms of what happens when we go beyond 90, and we end up with, negatives and so on as well. So these are all just kind of patterns that occur when different angles. Again, I don't think they're going to be necessary, although obviously not a bad thing to note. So we're going to move on to compound formulas. It's section 4.4 in the text. We're going to start with investigation on page 228, and this is the first part of it. I'm going to go do the first part of it and then leave you to kind of practice it. The first few questions that I assigned today will basically be doing the same thing, just kind of establishing that the formulas actually work. And then there'll be sort of one more set of questions today. We'll be on to 4.4 again tomorrow. So compound angle formula for cosine is this. Essentially, we're just giving you the formula. And the reason for it, you can sort of, if you look in the textbook, I don't have one open here. If you look in the textbook, you can see there is a proof there, but it is very lengthy. Certainly nothing that we'd expect you to ever reproduce. If you're interested, of course, read through it. You can ask questions about it, and we can see what we can clarify if you really want to. But essentially what we're looking for now is we're starting into proving things, and we're going to start by kind of establishing a good proof method here. And so essentially this is saying test it out, substitute these angles for the formula, simplify the expression. And so really we're trying to figure out, is in fact cos of x plus y, again, just sort of two angles that are unknown, the same as cos of x times cos of y minus sine of x times sine of y. And so when I do any kind of a proof, essentially I'm trying to prove that cos x plus y is equal to cos x cos y. So eventually, sorry, that's where we'll be. I guess we're really not there today. We're just asking the question, is this equal to this for an x value of pi over 6 and a y value of pi over 3? Now, the one thing we want to establish in is just good mathematical form. The one thing I cannot do is just start plugging in values and put in pi over 6 plus pi over 3 equals, because what will happen is, if in fact the numbers don't work out, if it turns out this is not going to be equal, then what I've been stating throughout my entire question, I'll be stating that this is equal to this, and then I'll plug in some numbers and do some simplification and work it out, and I'll get to the end where I get 6 equals 0. And essentially what that means is I've been lying all the way through my solution. It's a little thing, but at this level, we should not be lying in math. The nice thing about math, the reason math is everybody's favorite subject, the reason math is better than every other subject, the reason it's more important than every subject, the reason that we like it more, the reason that we enjoy it more, the reason that there's everything about it is more important, is the fact that we can always be perfect. I don't want to be a liar in math. I don't want to be making up statements that are not true. I always want to make sure that whatever I write is absolutely infallible. That's why we love it. So, I'm not sure if it's going to let me do this or not. Okay. So what we will do is we'll treat it like an actual question that says, are these two things equal? And we will establish sort of the standard left side, right side way of proving things. So on the left side, I have this expression, cos of pi over 6 plus pi over 3. That is equal to, guaranteed that is equal to, pi over 6 plus 2 pi over 6. No question about it. Nothing there could be considered wrong. Nobody could ever prove it wrong. And so cos is going to be equal to, that's going to be equal to cos of 3 pi over 6, which is cos of, pi over 2. And cos of pi over 2, if you punch it into a calculator, is 0. It's one of the ones that we don't actually know, but that's going to be the answer. Okay, so continuing on then, I'll work the right side the same way. Oops, didn't mean to do that. Just move it down a little bit. And so, again, avoiding any mathematical problems, my right side is equal to this in this case. Obviously, nothing wrong there. And then essentially I'm going to make sure that any substitutions I do are valid, of course, as well. Cos of pi over 6, so that's 30 is root 3 over 2. Cos of pi over 3 is 1/2 minus sine of pi over 6, which is also 1/2, and this is root 3 over 2. Lovely stuff. I get root 3 over 4 minus root 3 over 4, which is 0. And so in this case, the question was, the question actually says in 2 steps, sub these things in for the left side and simplify the expression for x plus y. So I did that to make it cos of pi over 2. And then the second part says use your special trig angles to work it out, which is essentially what I did there. So it's kind of question 1 and question 2 together. And then basically what I get to is I recognize that, I suppose I could say, therefore, for x equal to pi over 6 and y equal to pi over 3, the formula cos x squared cos x plus y equals that is true. Now, I'm not sure if I had something else I was going to go through. Okay, so basically, you're going to have two types of questions today. The first type will be like what we just did there. So I'll have you finish up the investigation, test that same formula for a couple of other values, and then the first couple of questions will do essentially the same thing. The second set of questions, and we'll sort of stick to the, the A-level questions at this point, will look like this one here in example 2. Determine exact trig ratios for other angles other than the special angles. And so what you'll be starting with is, oh yeah, I can't do that. Give me a sec. Okay, so the second type of question we'll have today, again, similar to this one, example 2. Essentially, you're going to be using the formulas we just saw to solve for, again, exact trig ratios for angles other than the special ones. The key will be sort of in the first step. This will be I think, the challenging part of the question. Essentially, what we want to do is rewrite an angle like pi over 12, for which we don't know any information, in terms of angles that we do. So you'll sort of have to try and kind of play with it a little bit and recognize that pi over 12 is the same as 4 pi over 12, 4 pi over 12 minus 3 pi over 12. This is one of those fractions that we know, pi over 3. This is one of those fractions we know, pi over 4. And so essentially you're going to be trying to write all of your angles in terms of, so right angles in terms of pi over 3, pi over 4, and pi over 6. Now, they may have other values involved, something like 2 pi over 3 or even 5 pi over 3. I know the exact trig ratio for, and so you may end up with some fancy ones at some point. Initially, I don't think they'll get too tough, but basically that will be the key, establishing what is the, what are two angles that I can use either added together or subtracted in order to get the angle that I'm starting with. Once you have that, essentially we're suggesting we can write sine of pi over 12 as sine of pi over 3 minus pi over 4, basically doing the opposite of what I just did in the first part. Instead of simplifying what's in the brackets and coming up with a single value, I'm splitting what's in the single value into a bracketed addition or subtraction, and then and then I can do the substitutions as I need to and get down to the final answer. I don't think this is the final answer, I just cut it off. But where is it? It might be. Part of it's hidden, so I can't see for sure. I think it's actually fine. So if you go simplify as far as we can, down to that, and then, oh yeah, the second part of the question, that's what it was just determine whether the actual angles are right, whether everything is correct, and you can punch it into a calculator and determine that I do have the same answers. So sine of pi over 12, if punched into your calculator in radians, gives you 0.2588. If you punch your final answer here, root 3 minus 1 over 2 root 2, into a calculator, you should get exactly the same answer. Okay, so those are the two types of questions you'll see for today. As I said, we'll end up with some more similar. We'll be working with these for a while now, and but this is just the starting point.